vertical motion model is an important tool for doing research out in the world. So that's why we keep coming back to it. You do not need to copy the text of the question. You need to read the question to yourself. And I am going to change one thing. I don't like the way this is. So you've read the scenario. We're talking about a rocket that's getting launched from 160 feet up in the air, a cliff. We don't have a huge number of cliffs in Florida, but maybe by the ocean we do. But all over the country, there's plenty of them. So a rocket is being launched, and its vertical velocity is 48 feet per second. 48 feet per second. That's its vertical velocity. That's in the function right there. So we're going to solve this. We already know that because I wouldn't have it in this lesson if we weren't. But we need to understand what's happening. So we need to review what the letters mean. To proceed, you need to understand what H is, and you need to understand what T represents. You're told in the text of the question, but I want to clarify one thing. H is the ending height, where the object ends up. That's H. S is the starting height, and that's right here. Starting height, 160 feet in the air. Ending height. In the past, you've seen a basketball player. I've talked about throwing a ball and another person catching it. The ending height is different depending on the scenario. In this scenario, I am asking you, how long will it take for the rocket to reach the ground? How does that part of the question factor into what we're doing? Kaylee, and then we'll come over to Gary. Okay, what were you going to say? H would be 0, and you said the ground would be 0. And you're both right. That's exactly it. For the purposes of doing research and studying, the ground would be 0. Now, we're actually on the second floor of a building. This is the ground of this classroom. If we were doing a scientific experiment in this room, then we could say that that's 0. But if we were talking about something more complex like a rocket launch, then 0 would be the actual Earth, not this floor. So again, it's based on circumstances. So Kaylee was right, and so is Gary. H is going to be 0 because the ground, the Earth, is 0, and I'm asking, how long will it take for the rocket to hit that point? So we need to take this and modify it with one little detail. We need to change this. So now we will end up with 0 equals negative 16 t squared plus 48t plus 160. And now we want to solve it. We could graph it, and that would be an absolute nightmare. Because the first thing you need is the vertex, and the vertex would be the opposite of b over 2a. We're already involved with fractions, and then we'd have to plug it in and get a nice big number, and it would be a nightmare to graph. It would take a while. But we have just learned today a more efficient approach. So run through your factoring checklist. What's the first thing on the checklist, Adrian? And you already know it? What is it?
8.
8.
Or 16.
Or 16? Which one would be better to use? Good, but there's also something else. What other detail do we want to take care of right at the beginning? Paige? We want to get rid of that negative. So we're not going to factor out a 16, we're going to factor out a negative 16. So we'll rewrite this once again. 0 equals negative 16 times whatever's left over. So go ahead, you write what's left over. Watch how easy this becomes. Could someone help fill in the rest of what's left? Go ahead, Cheyenne. T squared minus 3t minus 10. And so now we went from this really complex looking equation to something that should not really feel too intimidating. This quadratic right here. And we are not done factoring. Remember, you keep factoring until you cannot factor anymore. So we have one factor, it's negative 16. But now run through your checklist again. What can we do with t squared minus 3t minus 10? Yasmin? Yeah, we can unwrap the foil. In fact, it should be done already. We unwrap the foil. So go ahead. Could someone tell me what it is? You got 1, 2, 3, 4. Go ahead, Chanel. T minus 5 times t plus 2. Cheyenne, you agree with that? You got the same thing? Good. So again, I want to point out how this started out so complex, and then just because of our skills with factoring, we're able to turn it into something that's very manageable. So now, Yasmin, what's the final thing we need to do that you told us about earlier? At the end that we learned today? I know, I put you on the spot, made you uncomfortable, I'm sorry. Go ahead. That's right, and you actually technically put negative 16, you set that equal to 0 and solve it, but because that's not something you can solve, you disregard it. And then she's right, we do t minus 5 equals 0, and then t plus 2 equals 0. And solve both of those. Go ahead. No, what's your question? Well, you already answered my next 2 questions, so thank you. That was great. So my first question was going to be what are the solutions, and my second question was going to be what's the actual solution. So she already answered one of them. This comes out to t equals 5. This comes out to t equals negative 2. Give me a thumbs up if you're already at the point where you're doing that mentally. If you're doing it from here to here, you're doing it mentally? Good. Put your thumbs down. That's awesome. So, Cheyenne, which is the real answer? That's right. So, the answer to the question is, how long will it take? Answer the question. It's going to take 5 seconds. It's going to take 5 seconds.